Good afternoon, and welcome to the next edition of Programming with Sever in our Introduction to Python series. Today we're going to look at an introduction to string methods. In this video, we will give a brief reminder or review of escape sequences, and then we will look at string indexing and string offsets in Python, beginning with an introduction, then an exploration into the negative indices or negative offsets. Then we will look at slicing, again doing a base introduction, then looking at negative indices when constructing or extracting string slices. Then we will close with a brief examination of some classical string methods and looking at string conversions. First, let's review some of the basic escape sequences that we have seen in the course thus far. The following table contains a list of our familiar escape sequences. It is important to review these because we're going to discuss them in terms of some examples we're going to see later in this video. So for example, the first one, // while it's a two-character sequence in the language, it represents a one-character encoding of the backslash in a string. We'll see some examples of this in a few moments. So let's look at a first test string named test string. And as we know, a string is a sequence of characters in Python, and I have these characters written in their own individual boxes so we can look at their positions in the string very clearly. The string offsets or indices start at 0, which I'm illustrating now. So when we go to reference a string, we can reference them by their position or offset, as it's called, in terms of their location in the string. And as we have discussed in a prior session, we also have negative indices which reference the position of the characters counting backwards from the rightmost end. And in this case, you see the kind of the natural asymmetry. Characters, when we look at the indices reading left to right, we start at 0. Yet when we look at the negative indices starting from right to left, we start with -1 and not 0. And finally, we see the overlay. I've got both sets of indices overlaid on top of the same string. So let's look at our test string. And notice in Python, strings are defined, as we said, as ordered sequences of characters. Consequently, we can access those characters by their position. We often refer to this type of accessing as fetching characters from the string based on their offset or position. When we fetch characters by indexing, what we do is we provide the numeric offset of the desired character, and I'll illustrate this in the coming example. What is returned to the program is the one character string at the specified position or offset. So let's look at an example. So here we have test string indexed at 0. That is the escape sequence /n. And as I said earlier, don't get confused by the fact that the representation of the character takes two symbols, the backslash and the n, but the internal encoding is one character. Notice how I've organized the characters in the boxes to highlight their position. I have the /n in the first index written to occur as a single location. Okay, so let's run through these examples quickly. We have test string at 0, which is the \n, test string at 3, which is a single space. Test string at position 8 is the tab character /t. Test string at position 10, we can see from my mapping, is the letter I. With regard to negative indices, we can start looking at the rightmost end, counting right to left, starting with the index of -1. So what is test string -1? Well, it's the last or rightmost character of the string. We can see that's B. Test string at location -4 is the tab character. Test string of -23 is the new line character /n. And finally, test string at -29 is the character T. And I'm doing this by referencing all the negative indices that I've overlaid on top of the string. Now let me illustrate another way in which we can do this without having to write down both sets of indices, positive and negative. So first, let's take note that the length of test string is 42. We see that the indices start at 0, terminate at the rightmost character or last character of the string, B at index 41. Therefore, there are 42 characters in the string. So now another way to envision the negative indices using the mathematical formula, test string at -1 can be rewritten with a positive index, and that would be the test string at location the length of the string -1, which is test string at position 41, which is again is the rightmost character B. So looking at the mathematical conversions here, we see that test string at -4 is the same character as test string at 38. Test string at -23 is the same character as test string 19, which is the character in the 19th index. And test string at -29 is the same character as test string at 13. And these are the same characters that we did, same expressions rather, that we looked at a moment ago, but now I'm making the conversion. I'm making the conversion from the negative index to the associated positive index. That's what I suggest you do if you don't like working directly with the negative indices. Okay, so let's look at the next type of string operation, which is called string slicing. And here the slicing is extracting contiguous sections of the sequence in the string, known as slicing. All right, so the syntax for this operation is test string. You have a start position and you have an ending position. Notice it's the start position is inclusive, but the ending position is not. So I have two ways that you can kind of envision how to compute these substrings or slices of the original string. So let's imagine we're going to cut the string in two locations. So let's use as an example test string from 9 to 19. That slice, 9:19. So if you would cut the string in those two positions, starting at the 9th and starting at the 19th, notice you would extract the characters from the 9th index all the way to the 18th index. So you get the substring starting at the start position through all the characters consecutively to the end location -1. So that's a nice way to look at how Python envisions the slicing occurring. So in this case, test string from 9:19 would be the string first space line. Now let's look at some more examples of slicing. So here we have test string from 20 to 26. So first thing I do using this way, rather than imagining the scissors cutting it at those two positions, which we can do, you can also look at it with a little bit of arithmetic. So we take the 26, the ending position of the notation, minus the start position, which is 20. So we have 26 minus 20, that's 6. That always gives you the length of the number of characters involved in the extraction, or involved in the slice. So we know that it's 6 characters. Now where does it start? It starts at the 20th position. So we go to the 20th position, go 6 characters forward, and that is our string, which is the string second. Another way to remember this is envisioning the two slices by the scissors. And a third way is to just remember that you always subtract 1 from the ending position. So in this case, it's all the characters between 20 and 25. Of course, there are 6 of those, which is what I was referring to in my initial description. Okay, let's look at 14, the test string from 14 to 20. Again, the length is 6 here, which is 20 minus 14. So I'll start at the 14th position, which is a space. I'll take the next 6 characters. And I get space, line, slash new line, slash n. If you have the first index missing, which is the start index missing, that means begin at 0. So if we do that, that's just a shorthand notation. So if we do that, we look at the length, which would be 14 minus the implicit 0, which is 14 characters. So starting from the beginning of the string, which is offset 0, I will extract the next consecutive 14 characters. And if we have that, we see I have some initial white space of /n/t, followed by 4 spaces, /t/n, which is tab and new line, and another tab followed by the word first, as you see I'm indicating here. It can also be the case that the end position is omitted, so you just have 27 colon close bracket. And then in that case, you start at the 27th character and you go to the end of the string, which is, of course, you would use the string length of 42 in the computation. So you have 42 minus 27, which is 15. We'll have a string of length 15 characters starting at the 27th position. This gives us the string line with a /t and then the word tab. So this is kind of the way you can do it as well. You do it a little more slowly, but a little carefully by first computing the length involved in the extraction. Now, it's interesting with Python, as we mentioned, you can have negative indices, so you can also use the negative indices in terms of the slicing. So here we have negative 15 colon negative 6 as our slice in terms of the offsets. As I have the negative indices written at top, you can use the negative indices, go to the position negative 15, which is an L, and go and you can go all the way to the negative 6, but the character before. We can see this with the slicing as follows. We would make our cuts at the negative 15th and the negative 6th position. And what are we left with? We're left with the string line width. Now, once again, we can make the conversion away from negative indices to the corresponding positive indices by using the string length. Here we would say the test string from negative 15 colon negative 6 is equal to the test string from 27 to 36. We do that by adding the string length to each of the negative coordinates. Here you can still see the extraction cutting at positions 27 and 36. And even if you kept with the original negative indices, we would use my technique of computing the length. So it'd be negative 6 minus negative 15, which is 9. That tells us the extraction will have 9 characters. And then when we start at the offset of negative 15, take the next 9 characters, we still get the same string returned as we saw before. Now, let's look at this following example. So if we look at test string equal test string sliced from 0 to negative 1, where the 0 is written implicitly, namely it's omitted, what this really does is this returns everything but the last character of the string. Now, there are many instances in which you would want to do this. One of which is when you're doing file reads in Python. In some instances, the last, that is the rightmost character of the line that is read, may contain a new line. And if you want to go ahead and strip those new lines off, if you know that it'll be there, then this is a simple way to do that. You can get rid of that single character by using slicing in this fashion. There are obviously many other instances in which you would want to remove the rightmost character. I'm just illustrating one such example in terms of reading from files. What's nice about Python, the slices are part of the inherent logic that oftentimes has to be coded explicitly in other lower level languages. Here in Python, we have these mechanisms being afforded to us for free, so to speak. Moving forward, now let's look at some of the built-in string methods. And in Python 3, it's suggested that rather than using this, importing and using the string module, the strings have had a funny history in terms of the development of Python. So we still have a naturally occurring string module, but I believe the Pythonic way is to use the inherent string methods rather than perhaps some of the older techniques employed in the string module. Nonetheless, here are some examples of some common string methods, and we'll run through many of these in the next example. So how do we call the method from the object? Well, here's the syntax below. This part of it is the fetch. So when you see the object.method, that's actually saying fetch this attribute from the object. Okay? Now, since that attribute is a function, when we look at how to do the function call, where it's function name, parentheses, and an argument list, this means invoke the code of the function where you're passing forward the arguments. And when we combine these two expressions together, this is how, in fact, we invoke the method call. We have object.method, that's the fetch, and when you put the parentheses and the argument list, or you just have the empty parentheses. That's the actual call or invocation of the method being applied to that object. So that's the basic syntax. Let's look at some examples of that. So here we have a basic string. It was the best of times, it was the worst of times, a famous quote from Dickens. I have 8 strings that we're going to use. The first 5 of them will involve this string here, and then the last 3 will be done a little differently, just to show you that how it can be done a different way. So we look at string.capitalize. That's calling the capitalize method and applying it to the object string. What this does is it capitalizes the first character of the string, and I have here the output in blue. So while in my string the initial I in it was the best of times is lowercase, calling or invoking the capitalize method capitalizes the first character of the string. Moving on to the next example, the count. So here, when we invoke the count method, it's going to count the number of occurrences of the word or the string sequence was if they exist in the string. And here we see there are 2, and we return a value of 2. So the result 2 is the number or integer 2. Find returns the offset or the index of the first occurrence reading left to right of the word if it's found. So it would be at the 3rd position. You can see it's the second word, and if you count out the characters 0, 1, 2, 3 begins at the 3rd offset. And of course, if was not found in the string, it would return a -1. Now, the method is alnum, which stands for is alphanumeric. If all the characters are alphanumeric, you get a true. And here we get a false. Why? Because of the spaces and comma. Those are not in our alphabet, our English alphabet, including numbers. So string is alpha is also false for the same reason. We have spaces and a comma inside of the string. Now, in the 6th example, we're using a string literal, and we're going to call the function lstrip, which stands for left strip, and we're going to strip out all white space starting from the left. And you see we have 2 characters of white space in this string literal written in brown, the single space and the /n character. These are considered white space in Python. So if you left strip those out, it just truncates and returns everything starting with the capital H moving rightward, and that's what we see here in blue. Right strip works the opposite way. It strips white space from the right-hand side. So we'll see in this string the 3 characters of space, tab, and space on the right of the letter D will be stripped, that means removed, and the appropriate substring is returned, which I have here in blue. Finally, strip does both at the same time. It left strips and right strips each side of the string together. One side then the other, or you can conceptualize it as doing both at the same time. And what's interesting, I'll show you another way here for fun, how to induce the strip by using lstrip and right strip consecutively. So we'll see that here. So it's interesting to note that this is how you could code. You can imagine how the strip method is being coded in behind the scenes in Python. That's just an interesting example there. Okay, string conversions. There are a few more methods that we want to consider. Again, it's the same type of syntax that you would use in terms of calling them. You have to know the method name. Here they are: lower, upper, capitalized title, and replace. 2 versions of the replace method in terms of the parameter list or the signature of the method. And we'll go through each one of them in turn. Take a moment to pause to read the descriptions, and then you can resume and we'll look at how they may be used in practice. So here again we have 6 examples. The first 4 will work on this string, which is a famous quote by Walt Disney. The last 2 will be methods working on the string literal, run, run away. So string upper will return the string of all the alphabetic characters converted to uppercase. And you can see I have that here in blue. Everything is capitalized. Lower goes the other way. converts every character to the lowercase version of that string, which you see here. String capitalized, which we did earlier, it just capitalizes the first term. Remember, we did that back here, which was our first example, capitalizing the first character of the string. So here we're just revisiting it again. The fourth example, title mode, or the title, which makes the return string look what we call the title, where every word is capitalized. So notice in our quote, we've capitalized each and every word in the string. And that's what the title method does. Now the last two are replacing. So the replace method replaces the occurrence of run, if it exists in the string, with the string go. And I should say it replaces all occurrences of the string run, if it exists within the string, with the string go. So run, run away, if we replace the runs with a go, becomes go, go away. Okay? Sometimes you don't want to replace all occurrences. Sometimes you want to replace only the first n of them. So here in our signature, if we have n to be 2, it will replace the first 2, or at most 2, or up to 2 occurrences of the string run with the string go. So here we would have run, run away would return, when we call this function replace with these parameters, would return the string go, go, run away. The third occurrence of run will not be replaced with the string go. I'm Tim Sever. I hope you enjoyed this quick introduction to strings, string indices, string methods, and string conversions in Python, and we'll see you next time.